class 10. Today we are going to continue our journey into linear inequations. I've already made few videos. Probably this will be your last video on linear inequations, in which we are going to deal mainly on specific problems of when a graph or a linear equation is represented on a number line, and then from that number line we convert that. He asks you to write the corresponding linear equation by giving the graph. Like we will do most of the question based on this today. Like he has said, the diagram represents two inequations P and Q on real number line. These are two inequations which are represented on this number line. We have to write P and Q in the set builder notation. Generally, not generally, every time whenever the replacement set is set of real numbers, we will have to write the set in the form of set builder notation. We cannot express it as finite set or discrete set. We will have to represent it in the form of set builder notation. We can't represent it in the roster form. Simple as that. So he has given you a set P, he has given you a set Q. First we have to write these two sets in the set builder notation. After that, he has written certain sets like P union Q, P intersection Q, P minus Q, Q minus P, P intersection Q dash, and P dash intersection Q. And we have to represent those sets also in set builder notation, and then we have to represent them on the number line. So we'll take each one by one. First, I want to check the set P. Just look at the set P. It is a set of real numbers because this kind of representation is only for set of real numbers. At 2, if you notice at minus 2, it is greater than. When we move to the right on the number line, we are getting greater number. When we are moving to the left, we are getting a smaller number. But because the curve is in such a direction which is towards the greater value, so x is greater than minus 2. It is greater than minus 2. All the values which are greater than minus 2. And at 6, if you notice, at the number 6, if you notice, there is a straight line up. That means it is equal to 6. It is equal to 6. So how will I write it? X, such that x belongs to set of real numbers. Number 1. X belongs to set of real numbers. And what are the values? And x is greater than minus 2. X is greater than minus 2. It is greater than minus 2. It is not equal to minus 2. It is not less than, because we are moving towards the right. We are moving from minus 2 towards the right. The numbers are increasing. When you are moving from a point on the number line, when you are moving to the right, for example, here the number I have picked up is minus 2 because before that there is nothing. So on minus 2 we are realizing we are moving to the right. That means we are picking up all the numbers which are greater than minus 2 and less than equal to 6. Less than equal to 6. Wherever we are finishing at 6. On the number line, always number line will be indicated going towards infinity, from minus infinity to plus infinity. These arrows indicate that this number line is going from negative infinity to positive infinity. And in between, what are the numbers we are talking? Between minus 2 and 6. And how are we talking about? X is greater than minus 2. X is greater than minus 2. Had it been a straight line like this at 6 we have drawn, then it would have been equal to, but it is not. All the values which are taken are ahead of minus 2, not before minus 2. So x is greater than minus 2 and less than equal to 6. So this is the representation of set P in the set builder form. Now let's see set Q. This is P. Let me set check the set Q. Again x belongs to R. You can write R in the end also. There is no problem. X such that. This time I will write these values first and show it to you. Now x is here, if you notice, on the number line, it starts from 2 and finishes at 8. That means all the numbers between 2 and 8. It is plus 2. He will always show you certain numbers beyond 2 onto the left also, and where it is finishing at 8 to the right of 8. Always, whenever you are plotting the number line, you must also keep that in mind. For example, if it starts 2, then I must represent 1, 2 number to this side. And if I am finishing at 8, we should represent 1, 2 numbers on this side. Now, sorry, x is greater than equal to 8. X is greater than equal to 2. At 2 it is there. So greater than, because there is a line here from the perpendicular line. So that means it is equal to 2 also, and it is greater than also. X is greater than equal to 2 and less than 8. Less than 8, and x belongs to set of real numbers. You can write either this way or this way, whichever way you think. Both ways are correct. We have to represent we have to represent them on the set builder notation, where we say what are the values which x can take, and x belongs to what? To real numbers, because here it is a real number. Now, first part was to represent write P and Q in set builder notation, which I have done on this here. Now he says you have to represent each of the following sets on the different number line. For example, the first one is P union Q. P union Q means the elements of P and Q or Q, both. The elements which belong to P also, which belong to Q also, and there are some common elements, they will also be taken into it. So let's take A, P union Q. Union means elements of P, elements of Q, or elements of P and Q. Now that means we are starting from -2 from here and going till 6. Now you see the elements from 2 to 6 are common to both. Because 2 is here also, 2 is here also, 6 is here also, 6 is here also. So they will be included. The another thing is starting from -2 and it is finishing at 8. So all the values, we'll write x such that x is greater than -2, x is greater than -2 and less than 8. X belongs to set of real numbers. Now this P union Q includes all the values which are of P and Q and also common. P or Q and common values. It contains the value, it is combination. Union means, you know what does union means? Union means taken together. Union is a combination. So set P as well as set Q and common elements. The elements of P will be there part of this, elements of Q will be part of this, and common elements will be there. From below 2, they are not the elements of, if you see less than 2, they are not the elements of Q, but they are the elements of here, of P. So that is why -2. And here 6 beyond, there are no elements in P, but it goes in this. So x is greater than -2 and less than 8. How do I represent it on the number line? I have to represent this on the number line. 0, 1, 2, 3, 4, 5, 6, 7, 8. Because we are going till 8, so let's go to 9. Draw here. -1, -2, -3, -4. Now greater than -2, it is greater than -2 and less than 8, less than 8. You can draw it better by using your scale. I don't have a scale, so I'm just drawing a rough figure. but you can use a scalar and make it a little better look-wise. So all the values are starting from -2 to 8, but not -2. -2 is not the part of P union Q, because you can see only greater than -2. So greater than, all the values greater than -2. And less than 8. Less than 8. We are not taking any value beyond that, because they are not the part of either P or Q. Only till Q. In the set Q we have elements less than 8. So we have included less than 8 and greater than -2. So it becomes P union Q. The set P union Q. Let us see now the B part, P intersection Q. When I talk of P intersection Q, then I am talking of the elements which are common to P as well as Q. The elements which are common and is common to both P and Q. The elements which are there in P as well as in Q, which are only in P, will not be included in this. The elements which are only in Q will not be included in P intersection Q. In P intersection Q, the elements which are part of P and Q, both they will be elements of P as well as elements of Q. Then only we will include them in P intersection Q. For example, it is starting at 2. 2 is here, so we will take obviously 2 because 2 is here. Before 2, it doesn't have element, so I cannot consider so. So it will be greater than equal to 2. X will be greater than equal to 2 because 2 is here, 2 and greater than all are there. And it finishes at 6. It finishes at 6. Beyond that, it doesn't have element. So X is greater than 2 and less than 6, less than equal to 6. X is greater than equal to 2 and X is less than equal to 6. X belong to set of real number. So only these elements are there. 0, 1, 2, 3, 4, 5, 6, 7, -1, -2, -3. It says greater than equal to -2 and less than equal to 6. Equal to sign is there. Equal sign is also there. That's why we have drawn perpendicular lines on top of 6 as well as -2. And these are so all the elements between -2 and 6, including -2 and 6, are the part of P intersection Q. Let me see the C part of this. C part is P minus Q. You must have read this in junior classes. The difference of two sets, union of two sets. These are basic operations on sets. P minus Q. When I talk of P minus Q, P minus Q means the elements of only P. Only P. When I say only P, that means those elements don't belong to Q. Because there are some elements of P which belong to Q also. If you look at here, from 2 to 6, the elements belongs to Q also. P also, Q also. But we are taking P minus Q, that means from P you take out the elements of Q. From P you take out the elements of Q, that means these are the only elements which belong to P and not to Q. So P minus Q, that means the elements from -2 and less than 2. Because equal to 2 belongs here. So greater than, because not equal to here, so greater than -2, X greater than -2 and less than 2. X belongs to set of real numbers. So what are we talking? We are talking of the elements which belong only to P and not to Q. All these elements between -2 and 2 will belong only to P and not to Q. So when I say P minus Q, that means I'm talking of the elements which belong only to P and not to Q. So that will be, if I plot that on the number line, 0, 1, 2, 3, 4. And here -1, -2, -3. So we are saying x such that x is greater than -2 and less than 2. X is greater than -2 and less than 2. So x is greater than -2 and less than 2. So this is going to be the So these are the three things which I could do on this. Now I'll do the next one also here. I'll rub it out. This portion A, B and C. I've done A, B, C. I have to do D, E and F also. So I'll do it now. This will remain it is, but I'll rub it off from here. Now let us see D, E and F portion. Let us see D portion. What is the D portion? Q minus P. Again, we calculated P minus Q, in which we said P minus Q is a set which contains the only elements which are only in P but not in Q. When I say Q and minus P, that means I am talking the element which only belong to Q but not to P. Now Q start from 2. 2 is included here. It will go from 2 to 6. They are part here also. 2 to 6 part here also. We'll have to take out the common element. The only element which belongs only to Q but not to P. So from Q take out the elements of P. It is going till 6. So greater than 6 and less than 8. Greater than 6, x greater than 6 and x less than 8 belong only to Q and not to P. The elements which are greater than 6 and less than 8 belong only to Q but not to P. So x such that x is greater than 6 and less than 8. Let me plot that. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, -1, -2. Now it is greater than 6 and less than 8. This portion represents Q minus P. These are the elements which belong only to Q but not to P. Q minus P means the set the elements which belong only to Q but not to P. Let's see E. E is saying P intersection Q dash. Complement. Q dash is complement of the set Q. Complement means that when we talk of the complement of Q, that means you remove the elements of Q from the universal set. Here universal set is set of real numbers. You remove these elements. You remove all these elements from the universal set of real numbers, and you will get Q dash. You will get Q dash. That means Q dash will have all the elements but between 2 and 8. Between 2 and 8. The 2 will not be part of it. These elements which are there, the elements of Q will not be there. When I talk of Q dash, then all the elements of the real set, real numbers except the set Q. So set Q has to be removed and its intersection with Q dash, with P. So P is -2. Now where? All this element 2, 3, 4, 5, 6 till 6 are there. So let us remove from here and -2 to 2. -2 to 2. Intersection will be -2 to 2. Only the elements which will be there will be minus 2 to 2, because the intersection we are talking, intersection of this set, because it has got 6 till 6, so I cannot go beyond that. So x is greater than minus 2 and x is less than 2, x belongs to set of real numbers. Because these are the only elements which will be the elements of P, and of course these will be the elements of Q dash, because these elements don't belong to Q. These elements don't belong to Q. So the common elements are minus 2 to 2. So let us write. Minus 2 to 2. This will give you P intersection Q dash, and the last one is P dash intersection Q. Now again, P dash is that set which will not contain the elements of P but all the other elements. That means all the elements before minus 2 and after 6, greater than 6, will be part of P dash. All the elements which are there below minus 2, before minus 2, less than minus 2, equal to minus 2, and all the elements which are greater than 6 will be part of this set P dash. And intersection Q. Intersection Q, obviously it will start beyond 6, greater than 6 and less than 8. Greater than 6, because equal to 6 cannot be part of P dash. It has to be greater than 6. So x such that x is greater than 6 and less than 8 will be the, and x belongs to set of real numbers. So we will represent this on the number line 0, 1, 2, 3, 4, 5, 6, 7, 8, minus 1. Always indicate the arrows indicating the number line going from minus infinity to plus infinity. X is greater than 6 and less than 8. This is P intersection P dash intersection Q. This finishes your question number 1, in which we discussed, he has given you the diagrammatic representation of P and Q. They have represented number set P and set Q, or two inequalities on the number line. We had to write them in the set builder notation, which we wrote from here. Observing all this, then he said represent each of the following sets on different number lines, like P intersect P union Q, P intersection Q, P minus Q, Q minus P, P intersection Q dash, P dash intersection Q. For this you need to have knowledge of the set theory. You need to have the knowledge of the set theory, which you have done in 8th and 9th. So I'm sure you are aware of that. Even if you're not aware, I have explained it to you about what is union, what is intersection, what is the difference of the two sets, what is complement, and what is intersection union. These are the basic operations on sets. Okay, we said we have to obtain the inequations, to obtain the inequation from the given graph, or the equation, whatever you want to get. Now in this case, actually we are talking of inequation, so let's try inequation from the given graph, because we have a graph on real number line. We have to see that what kind of set does it represent. For example, if you see set A, here distinct elements are there. So obviously these are minus numbers also, plus numbers also. That means they are going to be integers, set of integers. It is start with minus 3 and finishes at 2. So I can say x x is greater than equal to minus 3 and less than equal to 2, and x belongs to set of integers. X belongs to set of integers. X is greater than equal to minus 3 because they are marked. Minus 3, minus 2, minus 1, 0, 1, 2 are marked. So either I write in this form, or I can write in the roster form also. I could have written it as minus 3, minus 2, minus 1, 0, 1, 2 also. These are the elements of this particular set. But because he wants to express in the form of an equation, I am expressing them in the builder notation. I am expressing them as builder notation. For example, if you look here, the circles are drawn across even on minus 4, minus 3, minus 2, minus 1, 0, 1, 2. But you will notice that here there is a blank. There is no shaded portion. That means they are not included in this. They are not included in this. That means these are minus 3, minus 1, 1. These are odd integers. Odd integers are not part of this. Only minus 4, minus 2, 0, 2 are part of this. That means these are even integers. Even integers is starting from minus 4 going till 2. So x is greater than equal to minus 4 and less than equal to 2. X belongs to integer. It is an even integer, It is an even integer. Because odd integers are not taken as a part of that. So you have to specify. Because we are talking of minus 4, minus 2, 0, 2. These are all even. They are divisible by, exactly divisible by 2. 0 is, of course, can be odd also, can be even also, can be anything. Here, minus 2, this is a set of real number. This is a set of real number. This is a set of real numbers. Here I say x is less than minus 2 and x is greater than minus 2 and less than 6. X belongs to set of real numbers. X belongs to set of real numbers. Here x, what is the value? X is greater than minus 4 but less than 3. X is greater than minus 4 but less than equal to 3. X belongs to R. Please notice here, where is less than equal to, there is this perpendicular line. It is here, greater than minus 4. In these two sets, you will notice, this is the single set, x, such that x is less than minus 2. X is less than minus 2 or x is greater than 2. X is greater than 2. X is less than minus 2 or x is greater than 2. In this f portion I have x and x belongs to set of real numbers. That you must try. What is the replacement set? X belongs to set of real numbers. Here x is between minus 2 and 4. So x is greater than equal to minus 2, less than equal to 4. X belongs to set of real numbers. X belongs to set of real numbers. In the next figure, in figure G, if you look at that, it is set of real numbers because this kind of representation is for set of real numbers. It is less than equal to minus 1. It is less than because it is going to infinity to the side. It is not stopping at a particular number. So we would say that x x is less than equal to minus 1. X is less than equal to minus 1 and x belongs to set of real numbers. All the numbers which are equal to minus 1 and less than minus 1 are the parts of this inequation. X belongs to set of real numbers. This is also set of real numbers. X such that x is what? X is greater than 2 and less than equal to 5. X belongs to set of real numbers. X is greater than 2 because this kind of sign is there, this curve is there. So this side, that means values which are greater than 2 are the part of this set, and at 5 we have drawn a perpendicular line, that means equal to and less than 5. So x is greater than 2 and less than equal to 5, x belongs to set of real numbers. Next one is x such that x is again greater than 2 because you can see at 2 this curve is drawn, and in this it is not stopping, it is going to infinity. It is going to infinity because this arrow indicates this is going to infinity. Like here it was a finite set, but here it is an infinite set, here it is also an infinite set. X belongs to R. There are no endpoints here, it starts at one place and goes to infinity. Now all these sets have got distinct elements, like it includes 0, 1, 2, 3, 4, so this is set of whole numbers. This is set of whole numbers. X is a set of whole numbers. And what are the elements starting from? You can say less than equal to 4. X is less than equal to 4. X belongs to set of whole numbers. The whole numbers are 0, 1, 2, 3, 4. The whole numbers are only 0, 1, 2, 3, 4. X less than equal to 4. X belongs to set of whole numbers. Here the sets are starting from minus 2 to 4. So I would say x such that x is greater than equal to minus 2, less than equal to 4. X belongs to set of integers. Set of integers, because negative numbers as well as positive numbers are there. Then here also it is a set of integers. X, so that x is greater than equal to minus 3 and less than equal to 1. X belongs to set of integers. So you have to choose your points correctly and you have to see what kind of set is it. Is the replacement set of real numbers? Whenever this kind of thing is there, you will get set of real numbers, or this kind of representation is there, that means distinct elements are there. This is going to be there like this. In the next part of the equation, we have this part where the graphical representation of the inequation is there. I have to represent this inequation in the set-builder notation. Now you can see it is greater than minus 4 and less than equal to 3. So x such that x is greater than minus 4, less than equal to 3, and x belongs to set of real number. So it is just the reverse of the question which we are doing. Initially we were given an inequation. From the inequation we were plotting them on the number line. Now the question is, they have given you the plotting of the inequation on the number line, and you have to find an inequation corresponding to the given graph. Like in this graph, next one, x such that x is less than minus 2. X is less than minus 2, or x is greater than 2. X belongs to set of real numbers. X belongs to set of real numbers. The elements between this and this do not belong to this set. Now here, these are again integers. These are integers. X is greater than equal to minus 3, and these are odd integers. We are talking of the odd integers. We are talking of odd integer. X belongs to I, x is an odd integer, is an odd integer. X is an odd integer. Then we have the next question where again integers, where whole numbers are there, x such that it is starting with 0, 2, 4 and so on. It is indicating it's going to infinity. So x belongs to the set of whole numbers and x is greater than x is a whole number, and that's it. X is a whole number. I don't need to indicate anything. It's starting with 0, 2. Only thing you have to even whole numbers. Even whole numbers. Because these are even whole numbers, not odd. All the numbers are even. If you see it, it is 0, 2, 4, then 6 and so on. So x is even whole numbers. And then here again, this is x is less than -1 or x is greater than 2. X belongs to set of real numbers. So I've done plenty of questions based on inequations, from inequation to represent them on the number line, or from number line you frame the inequation. These should suffice you.